Understanding the limitations of available resources is crucial in many situations. When online access is restricted, the ability to provide helpful information relies heavily on existing knowledge and effective communication. In such instances, it is important to clearly acknowledge the constraints and explain the approach to be taken. This may involve relying on personal expertise, referencing physical documentation, or employing logical reasoning to address the query at hand. Providing context about the scope of available information helps to manage expectations and ensures that the individual seeking assistance is aware of any potential gaps. A key element is active listening. Carefully consider the specific question being asked and break it down into smaller, more manageable components. Each component can then be addressed individually, drawing on available knowledge and resources. Where direct answers are not readily accessible, focus on offering guidance and potential avenues for exploration. This might involve suggesting alternative search terms, recommending relevant publications, or directing the individual to subject matter experts who may possess the required information. Emphasis should be placed on transparency and honesty. It's important to acknowledge when an answer is uncertain or beyond the scope of current knowledge. Avoid making assumptions or providing speculative information that could be misleading. Instead, focus on presenting what is known with clarity and accuracy. Offering to follow up with additional research or seeking assistance from colleagues can demonstrate a commitment to providing thorough support, even when immediate answers are unavailable. When dealing with technical or complex topics, it is essential to define key terms and concepts to ensure common understanding. This can help to bridge any knowledge gaps and facilitate more effective communication. Visual aids, such as diagrams or flowcharts, can also be helpful in illustrating complex processes or relationships. These visuals can be created manually or sourced from existing documentation. When presenting information, strive for clarity and conciseness. Avoid using jargon or technical terms that may not be readily understood by the individual seeking assistance. Break down complex information into smaller, more digestible chunks and present it in a logical sequence. Employing a structured approach can help to ensure that the information is easily accessible and comprehensible. Providing examples and analogies can also be a helpful way to illustrate abstract concepts or principles. By relating the information to real-world scenarios or experiences, it can become more relatable and easier to understand. This can be particularly useful when explaining technical concepts or processes. When answering questions, it is important to provide context and background information to ensure that the response is comprehensive and informative. This may involve explaining the underlying principles or assumptions that underpin the answer. Providing this context can help the individual to better understand the response and apply it to their specific situation. In situations where online resources are unavailable, it is important to adapt communication strategies to suit the available channels. This may involve relying on telephone conversations, written correspondence, or face-to-face interactions. Each of these channels has its own strengths and limitations, and it is important to choose the most appropriate channel for the specific situation. When communicating verbally, it is important to speak clearly and concisely, and to use appropriate language for the audience. When communicating in writing, it is important to use proper grammar and spelling, and to organize the information in a logical and coherent manner. In addition to providing information, it is also important to offer support and encouragement. This can involve acknowledging the challenges that the individual is facing and offering words of encouragement and support. It can also involve providing practical assistance, such as helping the individual to find alternative resources or connect with other experts. By providing both information and support, it is possible to make a significant difference in the lives of others, even when online resources are unavailable. Understanding the implications of electrical calculations is vital for safety and efficiency. Let's consider some examples related to electrical wiring and circuits. When working with electrical circuits, it's important to understand the relationship between voltage, current, and resistance, as defined by Ohm's law. Ohm's law states that voltage measured in volts is equal to current measured in amps multiplied by resistance measured in ohms. This relationship can be expressed as voltage equals current asterisk resistance. For example, if a circuit has a voltage of 120 volts and a resistance of 10 ohms, the current flowing through the circuit can be calculated as current equals voltage slash resistance, which would be 120 volts slash 10 ohms equals 12 amps. Understanding this relationship is crucial for determining the appropriate size of wires and circuit breakers. Another important concept in electrical calculations is power, which is the rate at which electrical energy is transferred. Power is measured in watts, and it can be calculated using the formula power equals voltage asterisk current. For example, if a device operates at 120 volts and draws 5 amps of current, the power consumed by the device can be calculated as power equals 120 volts asterisk 5 amps equals 600 watts. Understanding power calculations is important for determining the energy consumption of electrical devices and for ensuring that circuits are not overloaded. When selecting wires for electrical circuits, it's important to consider the ampacity of the wire, which is the maximum amount of current that the wire can safely carry without overheating. The ampacity of a wire depends on its size, material, and insulation type. The National Electrical Code, or NEC, provides tables that specify the ampacity of different types of wires. For example, NEC Table 310.15b16 lists the allowable ampacities of insulated conductors rated up to 600 volts, based on the conductor size and temperature rating. When selecting a wire for a specific application, it's important to choose a wire with an ampacity that is greater than or equal to the maximum current that the circuit will carry. For example, if a circuit is expected to carry 20 amps of current, a 12 American wire gauge or all copper wire with a temperature rating of 75 degrees Celsius would be suitable, as it has an ampacity of 20 amps according to NEC Table 310.15b16. It's also important to consider voltage drop when selecting wires for electrical circuits. Voltage drop is the reduction in voltage that occurs as current flows through a wire. Excessive voltage drop can cause electrical devices to operate inefficiently or not at all. The amount of voltage drop depends on the length of the wire, the current flowing through the wire, and the resistance of the wire. The NEC recommends that voltage drop in branch circuits should not exceed 3%, and voltage drop in feeders should not exceed 5%. To minimize voltage drop, it's important to use wires that are large enough for the intended application. For example, if a circuit is running a long distance, it may be necessary to use a larger gauge wire to reduce voltage drop. When selecting circuit breakers for electrical circuits, it's important to choose a breaker that is appropriately sized for the circuit. A circuit breaker is a safety device that is designed to protect a circuit from overcurrent. If the current in a circuit exceeds the rating of the circuit breaker, the breaker will trip, interrupting the flow of current and preventing damage to the circuit. The NEC specifies the requirements for selecting circuit breakers. In general, the rating of the circuit breaker should not exceed the ampacity of the wires in the circuit. For example, if a circuit is wired with 12 AWG copper wire with a temperature rating of 75 degrees Celsius, which has an ampacity of 20 amps, the circuit breaker should not be rated higher than 20 amps. It's also important to consider the type of loads that will be connected to the circuit when selecting a circuit breaker. Some loads, such as motors and transformers, can draw a large amount of current when they are first turned on. This inrush current can cause a circuit breaker to trip, even if the circuit is not overloaded under normal operating conditions. To accommodate inrush current, it may be necessary to use a circuit breaker with a high rating or a time delay circuit breaker. When working with electrical circuits, it's important to understand the different types of wiring methods that are permitted by the NEC. Wiring methods refer to the way that electrical wires are installed and protected. Some common wiring methods include rigid metal conduit, or RMC, intermediate metal conduit, or IMC, electrical metallic tubing, or IMT, and non-metallic sheath cable, also known as Romex. Each wiring method has its own advantages and disadvantages, and the choice of wiring method depends on the specific application. RMC is a heavy-duty wiring method that provides excellent protection for electrical wires. It is often used in commercial and industrial applications where there is a risk of physical damage to the wires. IMC is a lighter-weight alternative to RMC that provides similar protection. EMT is a thin-walled conduit that is commonly used in residential and commercial applications. Romex is a flexible cable that is commonly used in residential wiring. It is relatively easy to install, but it is not as durable as conduit. When installing electrical wiring, it's important to follow the requirements of the NEC. The NEC provides detailed instructions on how to install electrical wiring safely and correctly. Some important requirements include properly grounding electrical circuits, using approved wiring methods, and protecting wires from physical damage. Grounding is an important safety measure that helps to prevent electrical shock. Grounding involves connecting electrical circuits to the earth, which provides a path for fault current to flow back to the source. This helps to trip circuit breakers and prevent dangerous voltages from building up on metal parts of electrical equipment. The NEC requires that all electrical circuits be properly grounded. Approved wiring methods are wiring methods that have been tested and approved by a recognized testing laboratory, such as Underwriters Laboratories, or These wiring methods are designed to provide safe and reliable electrical connections. The NEC requires that only approved wiring methods be used in electrical installations. Protecting wires from physical damage is important to prevent electrical shock and fire hazards. Wires should be installed in conduit or other protective enclosures to protect them from physical damage. Wires should also be protected from abrasion, moisture, and other environmental factors. In summary, when working with electrical circuits, it's important to understand the fundamental principles of electricity, such as Ohm's law and power calculations. It's also important to select wires and circuit breakers that are appropriately sized for the intended application. Following the requirements of the NEC is crucial for ensuring that electrical installations are safe and reliable. Understanding electrical load calculations is crucial for ensuring the safe and efficient operation of electrical systems. Electrical load calculations involve determining the total amount of electrical power that will be required by a building or facility. This information is used to select the appropriate size of electrical service, wiring, and equipment. The NEC provides detailed guidelines for performing electrical load calculations. The first step in performing an electrical load calculation is to determine the connected load, which is the total amount of power that would be consumed if all electrical devices were operating simultaneously at the maximum rated power. The connected load is calculated by adding up the power ratings of all electrical devices, such as lighting, appliances, and equipment. However, it's unlikely that all electrical devices will be operating simultaneously at their maximum rated power. Therefore, the NEC allows for the application of demand factors, which are factors that reduce the connected load to account for the fact that not all devices will be operating at the same time. Demand factors vary depending on the type of load and the size of the building or facility. For example, the demand factor for lighting in a dwelling unit is typically lower than the demand factor for lighting in a commercial building. The NEC provides tables that specify the demand factors for different types of loads. After applying demand factors, the result is the demand load, which is the amount of power that is expected to be consumed under normal operating conditions. The demand load is used to select the appropriate size of electrical service, wiring, and equipment. In addition to the demand load, it's also important to consider the future load, which is the amount of power that may be required in the future due to expansions or changes in the use of the building or facility. The NEC recommends that electrical systems be designed with sufficient capacity to accommodate future load growth. When performing electrical load calculations, it's important to consider the different types of loads that will be connected to the electrical system. Some common types of loads include lighting, receptacles, appliances, and equipment. Lighting loads are typically calculated based on the square footage of the building or facility. The NEC provides tables that specify the minimum lighting load requirements for different types of occupancies. Receptacle loads are typically calculated based on the number of receptacles in the building or facility. The NEC provides tables that specify the minimum receptacle load requirements for different types of occupancies. Appliance loads are calculated based on the power ratings of the appliances. The NEC provides tables that specify the demand factors for different types of appliances. Equipment loads are calculated based on the power ratings of the equipment. The NEC provides tables that specify the demand factors for different types of equipment. In addition to calculating the total load, it's also important to calculate the load on each individual circuit. This information is used to select the appropriate size of circuit breakers and wiring for each circuit. The load on each circuit should not exceed the ampacity of the wiring or the rating of the circuit breaker. When performing electrical load calculations, it's important to use accurate information and to follow the requirements of the NEC. Incorrect load calculations can lead to undersized electrical systems, which can be unsafe and unreliable. Undersized electrical systems can cause circuit breakers to trip frequently, which can interrupt power and damage equipment. They can also cause wires to overheat, which can lead to fires. In summary, electrical load calculations are an important part of electrical system design. They involve determining the total amount of electrical power that will be required by a building or facility. This information is used to select the appropriate size of electrical service, wiring, and equipment. The NEC provides detailed guidelines for performing electrical load calculations. It's essential to perform these calculations accurately to ensure the electrical system's safety and efficiency.